Hello, Tom from Every Step Physics, EveryStepCalculus.com. Go to my site, buy my programs for $30. No problem spending thousands for college education. Buy my program, 360 plus programs to go in your calculator, your titanium, that will answer many, many physics problems step by step, okay? This one is a problem regarding planets. If it says planet in the problem, you're going to planets in my menu. And it regards sending a probe off the surface of some planet and finding out the initial or final kinetic energies of what's needed for that to happen. Physics to get to my main menu, press enter. I'm already at planets, which you would scroll down to in your calculator. And we're going to choose number 8 here. Press the number or the scroll down to it. I gave you Newton's gravitational constant, which he dreamt up in the 1680s, around that period. And it's miraculously true for all of our solar system and needed for all the calculations in our solar system. We're going to enter the major planet's mass. There's always a major planet in these calculations. For instance, our sun would be a major planet to us, the Earth. The Earth is a major planet to the Moon, etc. And any smaller planet is a major planet to a probe, which is very small in weight. So we're going to enter this one. I'm going to press alpha first before you enter anything in these entry lines in my programs, no matter which one, calculus or physics. And the mass is given as 4 times double E, which is scientific notation, times 10 to the 23rd power, 23 kilograms. If it wasn't, I would do the conversions for you and show you that so you can write it on your paper. And to the probe mass is 17 alpha, 17 kilograms. The radius is given as alpha. Alpha 3 double E to the 6. I have to be careful with this simulator. If you do it too fast, it'll screw up on me. Initial kinetic energy is given as 5 times e to the 7 alpha 5 double E 7. Distance given is 4 e to the 6 alpha 4 double E to the 6. Number 4 of the meters. I always give you the answers you've entered so you can see if they're correct. If they're not correct, you can change them. I say it's okay. And we do our calculations. Here's the formula: minus G times mass 1 times mass 2 times the quantity 1 divided by the major planet's radius minus the 1 over the distance, and then you add the kinetic energy. Okay, so we did all this with our variables that we just added, and then we slim it down doing certain variables and multiplying them, etc., finding answers as we scale down to get the answer. Write all this stuff on your paper exactly as this. And the final kinetic energy is 1.2203 times e to the 7 joules. Okay? So that's number A. Now we're going to go back here, press number 1 to new problem. We're going to go down to initial kinetic energy, number 9. And we're going to enter that. Have to enter the gravitational constant again, which I do automatically, but you have to memorize it so you can put it on your paper, of course, along with 100 other formulas that don't make sense to you, and yet you're going to have to call them up during a test. Enter the mass again, alpha 4 times e to the 23rd kilograms. Probe mass is alpha 17 kilograms. Radius again is alpha 3 double E to the 6 meters, number 3. The distance is given in this one, alpha 8 double E to the 6 meters, number 4. Again, we see if it's correct. It is correct. Press OK. And here's the formula here, minus G, just like we did here, except we don't add the final kinetic energy. And so we do the calculations, and we come up with 9.4492 e to the 7 joules. Okay, pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and pass physics. It's a tough class. A lot more valuable than calculus, that's for sure. All right. Hey, have a good one.